Okay, our next presentation, the title is Making the Case for Access Management, Innovative Techniques for Presenting Operational and Safety Benefits to the Public. In this presentation, we're going to learn how to promote the benefits of access management in any types of presentations that you may do. Peter's going to discuss a case study of a roadway widening project, and he's also going to show, give us some information on demonstrating how data was used to develop a performance matrix that emphasized design trade-offs. So Peter Kauffmann is a traffic engineer with Barge.
Barge Design Solutions. Yep.
Barge Design Solutions. It's a full-service civil engineering firm with offices throughout the Southeast. Peter is a Virginia native and a graduate of Virginia Tech. He has 9 years of experience analyzing transportation facilities, including traffic modeling, corridor studies, travel demand forecasting, and master planning. So let's welcome Peter.
So as we said, we're going to talk a little bit about a project that we did in Middle Tennessee. There was a roadway widening project, and we're going to talk a little bit about the approaches that we took and hopefully some of the lessons that we learned. So getting right into it, the problem that we encountered is that in any roadway design project, the public is really going to be concerned about what are the impacts to me. You know, are you going to take part of my front yard? How am I going to get out of my driveway in the middle of the rush hour? And as a result, they don't necessarily support access management options because they're focused on these things so heavily. We're used to presenting results about traffic operations and about physical impacts, and with just those metrics, access management solutions don't perform all of that well. So what can really be done to solve this? Well, let's start by thinking about what is missing in our customary presentations. We really need to increase an awareness of trade-offs and to provide some context about the choices that must be made. We also have to consider the needs of stakeholders in the process and consider not just what they're actually asking for, but also answer the questions that they really should be asking. If you were in Chris Huffman's workshop earlier today, he talked a lot about how to frame questions in a way that will bring the audience to the solution that they really need for safety. And that's another thing that it leads to, is the need to include safety data in the presentations that we're giving. Because really we have to remember what goes into our traffic analysis. Well, there's three major things. There's the physical impacts, how big is this thing going to be, how well is it going to work operationally, and then also safety impacts, both reducing collisions and providing facilities for multimodal travel in the corridor. And so we really need to bring that safety data into our presentations to the public and to elected officials, and not just show them the data. We need to give a way to elevate that safety data up to the level of the physical and operational impacts that people are used to seeing. We call this the three-pillared approach, which if you were in Chris's presentation, he had his own three-pillared approach. That's a different one. But a big way of putting safety impacts on the same level is by showing actual quantifiable data so that our discussion of safety impacts has the same rigorous analytical backing that they're used to seeing from, delay and level of service results. So we're going to go through each of these steps using a case study so we can understand exactly what the public's concerns were with regard to this project and talk a little about the data that we brought to the table. And so we're going to start off with a case study, and just taking a pause, Phil Demosthenes, since he hasn't gotten enough shout outs today, was one of the people who helped us on this project, and so a lot of the data that you're going to see were his good ideas, so just credit where credit is due right there. So this is a 3-lane U.S. highway in central Tennessee. It's a rapidly developing area outside of a major city. We're sort of anonymizing the names to protect the innocent, as they say on Dragnet. And so there's a number of commercial and industrial uses along this corridor. We've got fast food restaurants, we've got some light industrial uses, there's even a quarry along this corridor. And that means that during AM peak, there's actually as much as 11% of the traffic on our corridor is truck traffic, and that's during rush hour. So you've got your commuters and you've got your truck traffic. And that's something that we're gonna have to talk about how we accommodated that in a little bit. Now, the main reason we're looking at widening here is right now this 3-lane corridor, 1 lane in each direction plus a 2-way left turn lane in the middle, is carrying about 19,000 vehicles a day. And with growth projections from TDOT, it's expected to go up beyond 25,000 by the design year of the road. And so that's really going to be pushing, really going to be pushing it for a 3-lane corridor. So we looked at several different design concepts to widen the roadway. Obviously, we studied a no-build condition, keeping our 3-lane section as it is, and we also looked at 3 different alternatives that added a travel lane in each direction. We looked at an access management concept with a 4-lane section with left turn lanes and a median dividing it by popular demand from a lot of the property owners along the corridor. We looked at a unrestricted 5-lane concept, just adding a lane in each direction, adding some sidewalks, and putting a 2-way left turn lane down the middle. And then we also looked at a roundabout concept, keeping our access management options, keeping the median down the middle, but having roundabout control at all the intersections. If you're saying to yourself, hey, this is the access management conference, what am I doing talking about roundabouts? Well, roundabouts were actually a solution to the problem of truck traffic along the corridor. Because we had a lot of side streets here, like I think this one is actually the entrance to the county's municipal maintenance yard. So they had a lot of trucks coming in and out of here. And to get down in this direction, they're going to have to go up and make a U-turn someplace. And so there's actually these little U-turn pockets at a lot of the corners. And that one's actually sized for a P vehicle, an auto turn. It's a pretty wide radius for that. So we were going to have to find a place for the trucks to be able to turn around. And one way to provide that is by having a big circle in the middle of the intersection, which could accommodate large trucks. They just go up and keep turning left, and there's your U-turn. So as we'll see later, the roundabouts also gave favorable outcome in terms of traffic operations. So there were sort of a multi-pronged approach there. So let's get right into the data and start looking at some of the physical impacts. Now, the biggest shocker in terms of the public was those physical impacts. They took a look at the roundabout and said, oh my goodness, these things are enormous, and you're putting them right in the middle of the corridor. But in addition to the truck access benefits that we saw, there's also a benefit to be seen if you look just below it. And this section right here, by having the roundabouts, we did not need to have dedicated left turn lanes at the intersections. So you actually are able to narrow this bit between intersections down to a 4-lane section rather than the 5 lanes that you had to accommodate in either of those other options. And so there's really a trade-off that has to exist there. And the need to emphasize that was the first big lesson for us. It sounds very simple, but if you want to highlight certain aspects of the data, you need to call that data out separately. So we developed some graphics. You've probably seen something along the lines of this before, but just showing them the cross sections, saying if you look at either of these 2 sections, either of your 5-lane sections, either the 4-lane section with left turn lanes or the 5-lane unrestricted section, you're going to have a wider cross section between intersections. And so we were able to show them the trade-off between taking a big chunk out of everybody's front yard at every single property, or minimizing the takings between intersections and concentrating the impacts at the intersections themselves, which with the roundabout corridor, that gave us some flexibility because you can move the center point of your roundabout around a little bit based on how right-of-way negotiations are going and still have your roundabout function effectively. So again, that's the sort of trade-off that we're talking about. In terms of operational impacts, if you're a traffic engineer like me, you're probably wondering, how do the different alternatives perform? Well, we looked at things at a high level, and at a high level, we actually found that consolidating access at those major intersections, adding U-turns, adding more left turns, actually makes conditions slightly worse under the access management options. But what happened is that we found that there are benefits to be found at side street approaches. So if you're at one of these side streets and you have to wait forever to make a left turn in the morning, and instead now you're driven, because you can't do that anymore, to turn right, go up and make your U-turn and be on your way, those 2 movements may be of less overall delay than the left turn movement would have been originally. And so we needed to find some broad metrics to show this trade-off that exists. We needed to find some way to show that without it becoming a shouting match about, you're removing access at my intersection. We needed to aggregate it to get that overall conclusion to come through. And we'll show how we do that. So let's split up the data and look at it piece by piece. So in terms of travel time, everybody always wants to see what the travel time impacts are. This is just average travel time, all of our analysis periods, so AM, PM, and a midday condition, just averaged together. And we see with existing conditions, we're at 4 minutes 20 along this corridor, both directions averaged. With the no build, we're going to go up to 5 minutes 40, so things are going to get worse. And the different build alternatives give us some degree of improvement. Now, I'll admit the results are mixed in terms of our access management options. The 4-lane didn't really help that much, and that's because of the added amount of green time we had to have for left turn phases, because we have more left turning movements and more U-turning movements at those major intersections. The roundabout corridor concept did not have that problem quite as much. But if we look at the 5-lane concept, that's our unrestricted no access management concept, at a high level, we were able to lengthen the cycle lengths and widen the green band on the main line. But the question is, at what cost does that come at? And so what we need to do is we need to find another way to aggregate our delay and travel time data to highlight the trade-off that exists. So if we look at overall corridor delay for mainline traffic, the conclusions are generally similar to what we saw with travel time. Things get worse, and then with the various alternatives, they improve from the no-build condition. But if you're looking at the scale of this chart and thinking something's up, it's because we also wanted to take a look at the side street traffic. It's not just the main line volumes that we're concerned about. It's also how much delay does an average vehicle on the side street experience, somebody who's going into or out of a driveway. And when you add all that up, we actually see that the 5-lane concept doesn't perform quite so well, and our 2 access management concepts, the 4-lane and the roundabout, perform significantly better in that regard. By adding a median, we're actually restricting those high delay movements, and therefore the vehicles experience less overall delay. And this trade-off here actually struck a chord. This comparison between mainline traffic and side street traffic struck a chord with a lot of the politicians and the property owners, because we were able to ask them, well, who are you trying to serve with this improvement? Are you trying to serve the people who are cutting through your town, or are you trying to help the people who live or work or shop along this corridor? And that gave us a lot of ammunition to move forward and talk about safety impacts, impacts to people who use this corridor every single day. And the big issue here is, how do we quantify safety impacts? There's 2 main ways that we know of to do this. Conflict diagrams. If you've ever opened a traffic engineering textbook, you've probably seen conflict diagram figures. They've been around for a while. It's a good graphical way of showing where crash risk is, but they take a while to make. You got to draw it out. You got to count up all of your data points, and that takes a while. And we did it, and we'll show you what it looked like. But there's also a newer way of doing it, and that's with predictive crashes. It's a quantitative method of actually looking at the projected number of crashes that are going to occur given a roadway's geometry. And it's repeatable, and we can aggregate the data, and there are a lot of benefits to doing that. I'm not going to say it doesn't take a lot of time, because it does, but it's repeatable, you can bundle it up, and there are a lot of benefits to doing it. So let's take a look at each of those 2 in turn. Let's take a look at conflict diagrams first. So we drew them up for the entire corridor, all 13 major intersections, all the driveways, everything in between, and we added up all the conflict points, and we saw that our no-build condition had about 500 conflict points. And when we go to our 5-lane section, that number increases slightly, and that makes sense. We're adding a lane in each direction. There's going to be more conflict points. But by adding the median in the middle, adding access management provisions like the median, we're able to reduce that number significantly. And with the roundabout, because there's fewer conflicts at the intersections themselves, that number goes down even further. And so we're able to point at a map and say, hey, by removing this left turn, we're reducing the number of conflicts that exist around your property. And there is going to be a corresponding decrease in the crash risk that goes along with that. So we showed where the risk was using these conflict diagrams, but how do we actually hit home that without access management provisions that people are going to get hurt with this? And that's where crash predictions can come in. Has anybody here used highway safety manual calculations? We have a couple of people who have experienced the thrill of using highway safety manual. For those of you who haven't, it's got equations that are very similar to the highway capacity manual equations, in that we take a certain baseline rate and adjust it based on the factors that exist along the road. But that, like the highway capacity manual, is very complicated to do by hand. And so fortunately, there is software that exists to streamline that calculation. That's called the Interactive Highway Safety Design Model, IHSDM. It's for free. FHWA puts it out. You can go download it right now if you decide you don't want to pay attention to me anymore. But the output actually provides detailed breakdowns of data, the expected rate of crashes for each intersection and each segment, which we can aggregate along the entire length of the corridor. It also gives breakdowns by severity if that is a concern as well. So let's take a look at how we aggregated that along the entire corridor. This is the only figure we showed them about predicted crashes. What we're doing here is we're comparing a baseline level, and our baseline was the no build conditions. So this starting point is with the volume growth baked in, and that volume growth actually resulted in about 45% more crashes just from volume growth alone based on the predicted crashes. And so when we look at the different build alternatives, on the left side between intersections, we see two of the concepts perform better and see an overall reduction in crashes. And those are our access management, our median divided concepts, the 4-lane with a median concept and the roundabout corridor with a median. We saw about a 25% reduction in crashes along the entire length of the corridor based on IHSDM predictions. Now, the 5-lane concept with unrestricted, understandably, is going to have a significant increase in crashes. More lanes, more crashes. When we look at intersections, there's not as much of a change between the two signal corridors. The 4-lane and the 5-lane both had signal control. That's very similar to what you have at existing conditions, and so that keeps things generally the same at intersections. Roundabouts were associated with about a 30% drop in crashes. And there's a reason we're only showing percentages here. This was actually done at the request of the city. They didn't want to have the liability of having specific numbers of projected crash reductions. So if in the future those reductions don't occur, somebody doesn't come along and sue them. So that was something that we were asked to do and we're happy to do. And honestly, it probably works better and is more simple keeping it at the high level using percentages like this. Something else that we can also do with the IHSDM calculations is look at impacts at spot locations. When we presented things publicly, we kept things aggregated at a very high level so that we didn't have to dive down into the data too much. But at the request of some stakeholders, the city asked us to look at what would happen if we relaxed access management along a portion of the corridor, if we took out the median and reopened some access points. And so we were able to say, okay, here's the output from the program. We've got stationing along the x-axis, and we've got expected crash rate for that segment along the y-axis. And so originally we had a spike around this intersection, but generally a reasonably low crash rate. And what happens when we remove the median is we can actually show that there's going to be projection of more crashes along this section right where we remove the median. And so we can actually count that up along the corridor and give them an estimate of what that's going to do, what the trade-off is going to be if we try to appease these property owners by reopening things. So they, again, understand the trade-offs of what's involved in the different design decisions. So that's the data that we looked at, and let's talk a little bit about how we brought it together to show things to the public. And we gave them a color-coded chart like this. We added red, yellow, green color coding so that you can get some takeaways at a glance. We've got our different concepts along the top. They wanted us to compare to no build because that was something that the property owners wanted us to bring back into the discussion of not taking any of their property. And we have the 7 performance metrics that we developed and that I've just talked about. And what we actually see is in terms of physical impacts, understandably, the roundabout corridor is going to have more impacts at intersections. But between intersections, there's actually less of an increase than there is with the widened alternatives. There's no judgment there. That's just presenting a trade-off so people can make decisions. In terms of operational impacts, yeah, the unrestricted corridor is bad in terms of side streets, but for mainline traffic, it performs about as well as the roundabout corridor. And in terms of safety, again, the unrestricted option is very much red because we already have a 43% increase here, and we're getting even more than that, versus the access management having a median is able to at least reduce crashes from the baseline level in the future. So the common trend is essentially that the roundabout corridor is the best unless you happen to own property at one of the intersections. And so we made our case, and let's talk a little bit about how it turned out. Well, it was actually fairly well received by the general community. We got support from city staff, and after we gave the presentation, there was definitely an uptick in comments regarding safety concerns. And so city staff definitely was supportive of the desire to improve safety, the desire to have some access management to remove the couple of places where there's perpendicular parking accessing directly onto the street, doing some of these measures. And we actually got buy-in from some property owners who wanted to work with us to be able to have some flexibility and some say in what's happening at their particular property. And if you think there's a but coming, then clearly you've done one of these projects before, because despite all of our efforts, there was sustained opposition from certain businesses. In this particular municipality, the final selection is done by the elected city board, and it was an election year. And relatively recently, they wound up choosing the unrestricted 5-lane section with no median on a 5-3 vote. The fourth council member made a very impassioned speech about how she, wanted to improve safety along the corridor. But then at the same time, I'm hearing these complaints from property owners, and I'm going to vote with my constituents on this. So, a bitter pill to swallow, but that's elected officials for you. We still stand by the overall approach, though, and we learned some lessons in the process overall. The first one and the biggest one is to know your audience. You want to understand their concerns and anticipate their questions. Definitely provide answers that will address their concerns with a well-rounded picture of all aspects of things. Like those of us who were in the earlier session saw, you want to make sure that we're guiding them in the right direction to make appropriate conclusions and understand the trade-offs that are involved. Something else that we learned is to aggregate data. Keep it high level. We don't want to let individual concerns derail the conversation. We definitely want to do our homework and verify that a solution is workable, but know that those details are going to be ironed out in detailed design. Something else that was big is to get your municipality on board. We want to be able to use them in the messaging effort, and the municipality really should be seen as an advocate for the community. So later in the process, they still maintain the trust of the community members and can present data in an objective manner. And then finally, focus on messaging. You definitely want to think about how the data you present is going to be received. There were some times where we came in with, all right, we're going to show them all of this safety data, and that's going to sway them. They'll see how median reduces crashes and roundabouts reduce crashes and adding right-in, right-outs reduce crashes. And we came in fairly fast with some of that stuff to try to win them over. And to some extent, that kind of backfired on us. One of the leaders of the opposition at one point accused us of doing a sales job for roundabouts, which the roundabouts were performing best in all the performance measures, so we kind of were. But that sort of gave them a little bit of reason not to trust us so much. They thought that we were trying to sell them on something and not listen to their concerns. And fortunately, we still had the support of the city, so we were able to take a step back and have the municipality to take a step forward and presenting the data down the home stretch. But I kind of wonder if we had maybe taken a little bit more slowly, could we have won them over with more of that one-to-one interaction that we really need to win people over on access management? So that's the data I have to present. I really hope this is the start of a conversation. As you saw, we were not quite successful in the end, and if people have suggestions on ways to maybe carry this over the line, I am all ears. Definitely come find me during the reception if you want to get wonky about the data as well. All right, thank you. Yes.
For the different scenarios or different options there, did you have estimates on right-of-way acquisition, or did you present estimated dollars and cents on how that would all work out? Did that factor in the decision?
So the question is, did we have estimates on right-of-way acquisition and construction cost? So we had a rough estimate of right-of-way acquisition for the actual roadway itself, but we held off on talking about that because we had not done enough detailed design to show tie-ins for grading and that sort of thing, because we knew there were going to be wider construction easements, and we didn't want to show one line and then come back and have the line be further out. Generally, the overall square footage was about the same, and construction cost was actually fairly comparable over the life cycle of the project. Obviously, you have more upfront costs with curbs and things with the roundabouts, but over the maintenance, that's some data that we didn't show publicly, but we were able to show to the city and to the board to show them that the different alternatives were all fairly comparable in terms of construction in the grand scheme of things.
Seems like a benefit cost ratio if there's sum this all up, do you have one that would show?
We do not. That's actually a good idea. The question is, do we have a cost-benefit ratio showing for the safety impacts or for the travel time impacts? Or
Combine both of those.
That's a very good thought. That's not something that we had. I wonder how well that would be received by lay people who aren't used to looking at cost-benefit ratios. But that's definitely something to consider for the future to, again, aggregate it even more directly so that we can actually compare the alternatives with, have another data point to compare those alternatives. That's a good idea.
I was going to ask a similar question because I think for many people that might be valuable, but for upper level decision makers, it might help sway them. In terms of communicating with lay people, how did you get any questions about how did you come up with this information from members? And if you did, how did you communicate with them, considering, I'm sure, the level of work that went into what you did?
All right, so you're asking, did we get questions about how we developed some of these performance metrics? And we definitely did. And we had some open houses and were able to interact with people one-on-one to show them how things came together. In terms of the actual elected officials, we had work sessions where we actually walked them through the data in sometimes agonizing detail to try to make sure that they understood that we knew what we were talking about. And the elected officials weren't the ones who were doubting what we were giving them. It was the people along the corridor who were looking for any excuse to discredit what we said, finding a typo in a slide and then saying, well, the other day you said this. And it's like, well, actually, sorry, that was a mistake on our part. And then they're like, oh, well, these people don't know what they're talking about, which that happens all the time. The other part of your question, oh, yeah, and then we were also, did I talk about work sessions with the officials? Yeah, and okay.
Yeah.
There was a second point that I thought I had, but I've forgotten it now.
It looks like there's maybe pedestrian crosswalks on the design schematics. Is there actually transit service on the corridor, and there are impacts to transit users and pedestrians considered as part of the design affiliation?
So we definitely can, the question is impacts to transit users and pedestrians, were they considered in the design alternatives? So there are obviously differences in crossings at the intersections themselves, at the major intersections, but otherwise all of the concepts were fairly similar in terms of they're going to provide sidewalks on both sides and a wider shared use path on one of the two sides, which getting business owners to agree to that additional 10 feet of development where there aren't crosswalks or sidewalks along the corridor currently. Getting business owners to agree that we're going to take that additional bite out of your property was a tough sell, and in fact is still something that is being hammered out even now that they've selected the 5-lane unrestricted alternative. In terms of transit service, yes, there is a bus, but it has one stop in a shopping center at the very southern end of the corridor. It's developing, certainly. There is actually in the this big green patch right here is now a 5-story apartment building, for instance. So there's definitely going to be more demand for that sort of multimodal use as time goes by. But right now, we're trying to put in the infrastructure to accommodate that, but the demand is not there just yet. Does that answer the question? And in the back.
Maybe I apologize if I missed it. What's the distance between the two roundabouts?
So there were actually going to be, thank you. The question is, what's the distance between the roundabouts along the corridor? And there were actually going to be, depending on the concept, between 5 and 7 roundabouts in a 1.3 mile segment. So it would be a multiple roundabout corridor. I think I don't remember the spacing offhand. I'd have to pull up the plans and tell you, but it was, I think the closest one was 400 feet between intersections. I'm trying to remember the number.
And were there roundabouts in the community prior to this, so they have some experience about how they operate?
Were there roundabouts in the community currently? In the center of town, there is a traffic circle, which most people thought of as a roundabout, but we had to do some education on that. These are modern roundabouts, and there was a little bit of fear is the wrong word, but there was definitely some unfamiliarity. We had to do a lot of education about roundabouts that are going in. They did have one in a different part of the city, which had some other issues with it, and that's a different story. So they perhaps didn't have the best introduction to roundabouts. That might have been part of the hesitation with the roundabout corridor as well. A very good point. I think it's about 2 o'clock, so. All right. Well, thank you everybody for your time. Come find me after if you have questions.